And my presentation today is going to be about the Axum web framework. I would like to start by introducing myself for those of you who don't know me. My name is Tomáš. I work as a Rust backend engineer at Sonalake. You will be able to find my LinkedIn and GitHub profiles in the slides. And today's presentation's goal is very simple. I would like to show you guys that Rust is indeed ready for web server development. Maybe some of you have already tried Rust for web server development, so you don't need this sort of argumentation. But I think it will be a nice overview of the Axum framework regardless. So the agenda of today's presentation is going to be, we're going to have some introductions to the web. We're going to have some I'm going to name some features of the web framework in general, and hopefully the most interesting part of this talk will be the examples from Axum framework. So we will be looking at some source code. I hope you're looking forward to that. So I would like to start with a simple 101. I think most of you guys are familiar with this, but I just want to make sure we're all on the same page. So on web, you can have a static website, and in case there is a static website, the way this works is that your web server makes a request, your web browser makes a request to your web server, and your web server uses the URL of the request to find some file on its local file system, and then reads that file and uses the contents of the file to create a response, which it sends back to the web browser. If we were to make that a little more generic, and convert it to web services, there are some assumptions that we can relax. For example, the requesting party doesn't have to be a web browser. It could be another program. The web server's response doesn't have to be based on a file. The web server could, in fact, respond with different payload each time. And also, the response doesn't have to be HTML. So it could be JSON, it could be XML, it could be whatever your heart desires. With that said, let's take a look at what is a web framework. A web framework, in our case, is going to be a type of crate which offers some functionality related to web. That is pretty simple, and today we will be focusing on the server side only. If any of you guys have more knowledge about some client side or front-end frameworks in Rust that you'd like to talk about, feel free to let me know. We can arrange that. For us, web frameworks allow us to focus on implementing the business logic rather than focusing on the accidental complexity and server-side implementation details that we would prefer to have hidden. And the point of my presentation is to show you what are the implementation details of the server and how Axum helps us with them. So the notable features of web frameworks, I have tried listing them here. This list is not exhaustive, but these are some that I thought were interesting for us. So there is some network I/O, because the web server needs to somehow be able to pick up the connection and write some data back to the connection so that it can communicate with the client that made the request. There is some serialization and deserialization for the requests and responses because the HTTP protocol defines what they should look like. And while implementing the business logic, we may not want to focus on what the response or the request exactly looks like. We just want to have them parsed nicely in some new types that already provide some guarantees for us and make it easy. There are other things like middleware, routing, observability, error handling, and testing, and we will be talking about them you will hear about them in the next sections, so I'll be talking about them more. Now, what about Rust? In Rust, we have multiple web frameworks, which are already, some of them are well established, some of them are new and emerging. For example, ActixWeb is a well-known and stabilized and maintained web framework that is ready to be used. You might have already heard about Actix because it's quite popular. It's probably one of the most popular in terms of crate pulls, but you can check that information for yourself if you'd like. There are some other interesting ones. Pavex is a very interesting one. It's an emerging web framework which is still in active development. And basically, the idea of Pavex is that It is using code generation to give you better error messages than the other frameworks. So it is highly interesting, and I suggest that if you're interested in web server frameworks in Rust, you should definitely keep up with PAVEX updates. Then there are other frameworks like Axum and Warp, which are somewhere in between. So they are newer than Actix, but they are not as modern as PAVEX. Yet they are, in my opinion, ready for production use. You can obviously learn more about these crates on crates.io. There is a whole category on web programming HTTP server. I'm sorry, was there a question?
Yeah, you said Axum and Warp are not as modern as PAVEX?
Yeah, PAVEX is newer than Axum and Warp.
Okay, so those are more developed.
Yes, they are more developed.
Thanks.
Yeah, sorry. Are there any other questions so far? Yeah, this is as I said, this is an overview. You can go ahead and check them out for yourself if you're interested in them. And yeah, there's a whole category. I think there's like 800 crates in this web programming HTTP server category. So you can really dive in and find one that you like. Now, why should we look at Axum? Why is Axum interesting? This is highly opinionated slide, so feel free to take it with a grain of salt. In my opinion, Axum is beginner friendly, and I'm saying this from my own experience where I'm basically helping one company adopt Rust for web server development, and there's a lot of engineers who are beginners with Rust, and Axum is really the framework where they were able to come in and pick up whatever we had before and contribute to the code base. So it was easier for them to work with Axum than with other frameworks. I mean, this is highly subjective. You can definitely argue that other web frameworks are just as beginner-friendly. I'm just saying that from my own experience, Axum was one of the most beginner-friendly ones. Axum is also pretty bare bones. So if you take a really basic example of Axum, it's not going to have a lot of features, but also it will be easy to understand for people. So they don't have to, there's not a whole list of things that they would have to look at in order to understand the basic example. It's very straightforward. While being bare bones, it's also very modular, so you can pull in features if you'd like, and I hope that this will be more clear when I show you the examples from Axum. Apart from that, Axum places less constraints on handlers. Handlers are the functions in Rust that will be called whenever your web server gets a request. Some other web frameworks have arbitrary constraints, like your handlers cannot have generic parameters, or your handlers cannot be functions associated to a structure, or other constraints that might seem counterintuitive. For some people, it's like, why would you want generics in a route handler? It doesn't make any sense. And some other people are like, I need that absolutely. Why is it not in there? So it is highly subjective. Axum also offers comprehensive documentation for everything. You can easily learn about Axum just going to docs.rs/Axum and read on the chapter that you're interested in. And the last but not least, the point is that Axum uses Tokio and Tower ecosystem. So if there is a Tower middleware that solves, for example, timeouts or tracing or some other things, Axum takes advantage of that middleware. So I think these are some good reasons to be interested in Axum. Maybe it is not a framework of your choice, but it might still be interesting to look at the principles and why and what Axum does and how it does that. So this is my first look at Axum for you. This is basically Axum Hello World. This Hello World example, I'm going to talk you through that, so don't worry if it seems overwhelming, but I think it's a pretty simple program, so it should not seem overwhelming. So the first look at Axum Hello World consists of two functions. Basically, there's a main function, which is a Tokio main function, and the other one is a simple function that just returns the string Hello World. There's no background knowledge that you need about this. This really is that simple. So the main function, what it does is it creates a router, and registers a single route with the URL slash, and it calls this, it uses this get HTTP method from Axum to call the hello world handler. Apart from the router, we create another thing which is listener, and the listener is the thing that deals with the network I/O. So you can see that this is something from Tokyo that binds to the port 3000 on the local machine, and finally the Axum serve function combines the listener together with the app, which is the router, and what the serve function does is it starts the web server, and the web server starts listening forever, basically. This is the anatomy of a simple web server in Axum. And yeah, I should restate that if you send an HTTP request to this machine that is running this web server onto port 3000 using the URL slash and HTTP method get, you should get back a string hello world. That is what the web server does right now. So after we took the first look, we can take a look at the individual things that I listed under the features of a web server framework and talk about how they are addressed in Axum. This is an example which shows us how routing is solved. Basically, the problem of routing is that we have some web service that serves multiple endpoints, multiple URLs. And we would like to invoke different functions depending on what the URL is. Now, in this case, you can see that this example is not showing the listener or the Axum serve, but I am just assuming that that is not the interesting part of the routing problem. The interesting part of the routing problem is just creating the router. So we can, I think we can afford to omit that part. So in this case, we have a web server that supports these two URLs, the /URL and /foo. The /URL supports the HTTP method get, and if the /URL is called with HTTP method get, it is routed to the root function, which is a handler right here. The second URL that is supported by this web server is the /foo URL, which supports both get and post HTTP methods. If the get HTTP method is used, the get foo handler gets called. If the post method is used, the post foo handler is called. I think this is pretty straightforward. There are question?
What on earth is that syntax like get with an argument? So not in the second router, get with an argument, then a dot, and then post. I mean, is post some structure of get or some?
So this get function, if I were to go a little more in depth, this get function returns something called a method router, and the method router essentially contains something like slots for each HTTP method, right? So we can essentially, this means that we are filling the slot of a method router, the get slot of the method router, using the get foo handler. And now we can chain that, right? We can add the post to it. If we wanted to, we could add put, patch, delete, trace, options, whatever we can think of. Does that make more sense? I admit that this syntax is a little bit confusing here. Like, what is get root? Why are we calling a function that takes a function? But this is actually.
That was kind of okay. What got me confused is that between get and post in the second router.
Like, how are they chained, or why are they chained? More questions?
Is Axum somehow avoiding procedural macros? Because
that is a great point.
Have been much more readable.
That is an excellent observation, and yeah, the answer is yes. Axum does try to avoid procedural macros as much as possible. Okay, I'll do a little poll because I'm curious. Who likes procedural macros in their web frameworks? Please raise your hands.
We use them or write them.
Who likes them? Like, if you had the choice, do you want to use procedural macros in your web framework? Yes or no?
We use them a lot, but I don't like them to write. Depends on how much of a black magic it is.
Yeah, that makes perfect sense. I mean, there are
procedural macros I like are Sergey.
Yeah, that's a good one. Serde is, I really love Serde macros. All right, so this is about routing. Let's take a look at something. Question?
You can go back to
Sure.
routing. Is there a way to?
Oh, sorry.
Well, yeah, thank you. Is there a way to nest routes if you have a common prefix, for example?
There is a way to nest routes, yes. I did not make it a part of this talk, but what you can do is you can, I think there is a function on the router. I can't recall the exact name. It's probably something like merge, and you can essentially pass a router into a router.
So if you have, let's say, a resource represented in web framework in your backend.
Like a user, for example.
Yeah, exactly. So you could then chain based on the common prefix with nesting.
Yeah, you could make a router which is only concerned with the user routes, something like /user/user ID, and then add all the HTTP methods that you want to support, and then nest it with the main router of the application.
And if there is, for example, let's say some extractable path variable, then you're also able to extract it in some way, or will you show it in?
Yes, I will actually show it in the next slide on the user ID. So, yeah, any more questions on the router nest? Okay, so this problem is about request parameters. I tried to merge maybe some concepts that might seem different for different people into this one slide. But basically for me, request parameters could be query parameters, which is the part that is after the question mark in the URL. It could be path parameters, like you can see here, where we have the user ID inside of the URL, or it could be a request body, of course. So there are different flavors of these request parameters. But on this slide, you can see examples of three ways to extract parameters from a request. Let's see, what does this example show us? So we can see that in this example, we create a router that supports 3 URLs. One of them is /path/user ID, then there is search, and then there is form. The first route only supports get, and the other 2 routes only support post, and they go to their respective handlers that are declared down here. Now, let's take a look at the first route. This first route contains a :user ID specifier, and this is what you were asking about, that we can add some parameters into the path, and then we can extract them in the handler. In this case, Axum knows that whenever we prefix something with a colon in the route registration section, that thing turns into a path parameter. And we can then use the path extractor down here to extract that value. In this example, we can see that there is a U32, which means that we are expecting the user ID to be an unsigned 32-bit integer. We have similar concepts down here. We can see that query works in a similar way. So we are just saying that we are using the query request extractor, and the query request extractor is used to extract a hash map of string to string. The third one is processing a form. And in this case, the form is part of the body request. It's just a reminder. The form is part of the body request, and we are extracting a form that represents a hash map from string to a string. Yeah, does that make sense to everybody, or are there any questions about this?
Will we cover how Axum handles extraction errors later?
Yes, that is the next slide. Thank you for the question. Right, so the status where we cannot parse the request parameter is called rejection in Axum. So how do we deal with it? How do we deal with rejection? Well, Axum offers a followable implementation. So one option here is to use a result instead of using the request extractor directly. So in this case, my router just supports a single URL, which is the getUserById. And it is using the getUserById handler, which is extracting a result instead of extracting just the path itself. This means if someone were to send a request, something like /path/blah blah blah, they would still invoke the getUserById function, but we would not receive an OK variant of result. We would receive an error containing this rejection. And now the handler has to deal with that. And what the handler does with that, that is up to the handler. I would like to move on to responding. Like, how do we respond? How do we write something into the response? The good news is that you have already seen that. Sending a response body is quite straightforward. You can see that this is a simple router which supports a single URL with the getHTTP method, and it is routing the requests to this hello world handler. And this hello world string, that actually ends up in the response body. So I think this is quite straightforward, and I think you can see that it's easily possible to swap this static str to some other type. You could return JSON, you could return XML. Question?
Is the content type for the response automatically set?
So in this example, no. Axum in general does not do that for you. If you use one of Axum's responder, for example, if I were to wrap this in JSON and Angular brackets, the JSON responder would set the content type. But I will have an example that shows how to set headers as well, so maybe that will be more valuable to you. So this is how we send a response body. And we can, along with the response body, we can set a status code if we'd like. So in this case, I would like to show you how to return a 404 error code, because 404 is the one that is the most famous one. So this hello world request handler returns a pair instead of returning just one thing. And what the way this pair works is that the status code has some influence on the response, but it does not influence the response body. It just sets the status code to not found. And the response body is taken from the very last element of this pair, which is a static string. So this response is going to have the response body of hello world, while the HTTP status code is going to be set to not found, or 404 if you'd like. There are some different things you might want to do with a response. Setting status code is just one of them. You might want to set headers, for example, and this is how you set headers. So instead of returning a status code, as we saw in the previous example, we can return something called a header map. And this header map, it works in a very similar way to hash map. What you can do is you can insert names and values, and then you can attach that header map to the pair that your handler is returning. So in this case, this is the example of what you were asking about. How do you set the content type? This is how you can set a content type. There are obviously more header names defined in the header name library, and I'm pretty sure this accepts a string if it's as long as the string represents a valid header name. So yeah, this is how you set headers. I hope that makes sense to everybody. What is next? So now imagine that we have a more elaborate request handler which responds with a string in one case, and in another case we might want to set a status code and respond with a string. So there would be a mismatch between the types of responses that we want to return. So how do we solve that? In this case, our getUserById handler takes a user ID, which is going to be a result of the path U32. So it's going to extract the path or give us an error. And inside of the handler itself, we are going to match on the result of the extraction. I'm sorry for this mistake. This should be a user ID, not the result. But essentially, we are matching on this result here. And if it's OK, then we return a string. And if it's not OK, we want to return the status code not found and give the user a error message that they can understand. So the important part of this example is that your request handler can return the response type, which is part of Axum, and all of these things that we were returning, the string, the static stir, the pair with a status code and static stir, and also the other pair, they implement into response trait, which is available in Axum. So what I did here was that I created this string, and I called into response on that string. And I did the same with the pair down here. So now both of them have the same type, and I don't have to deal with the compiler telling me that my match arms have different return types. So yeah, this is how we can deal with different response types.
Can I ask a question?
Mm-hmm.
The parameter type, we've already seen this on a previous slide, but does Axum not have a utility results type that would not force me to write type out path u32 two times?
Mm-hmm. That is an excellent question. I confess I don't know the answer. Maybe there is one for this, and it would make a lot of sense.
I didn't find it in their docs.
Uh-huh. So it might not exist. Well, I feel like it might be pretty easy to write it by yourself. But yeah, it should be part of Axum, right? Yeah, I agree with you. That was actually a great question because my next slide is about moving some logic out of a handler. So you guys will get at least some idea of what it's like to write your own request extractor. If it's not clear for some, a request extractor is a type that is used up here as a type of parameter for the request handler. Now this request handler here, so what I wanted to do here was I wanted to take the previous example where we were matching on whether the user ID was successful or not, whether the user ID was valid user ID or not, and present an error message if not, and give them some string if it was valid. In this request handler, we simplified that a lot by introducing a request extractor, and essentially this request handler then becomes concerned only with the positive happy path, or whatever you want to call it, with the path where the user ID is valid, and you can move the code that parses the user ID to this separate snippet, which may not look as appealing as it did before. But the big pro of this snippet is that you can now reuse that, right? If I had 20 more routes that deal with users, I can just take this and reuse the user ID in every single one, and I don't have to keep it consistent. Like what happens when the user ID is invalid in route A, and what happens in the route B? I can just reuse the request extractor. So this is quite neat. So how does a request extractor work? How do we implement a custom request extractor? Well, in Axum there is a trait called fromRequestParts, and that trait. So the answer depends on what you are doing with the request, because if you look at this request extractor, it doesn't touch the state. So it doesn't rely on the state being something in particular. It could be anything. So this particular user ID extractor, in my opinion, it makes sense to make it generic. And even this trait is generic, so the generic type, the generic parameter, it has to be somewhere. But you can see that user ID itself no longer needs to be generic. Now let's look at the state. I think, let me just restate the problem. So the problem here is, let's imagine we need to access database in the route handler, or access some configuration or something that was available during service initialization, but isn't dependent on the request itself. In this example, it's going to be a database connection pool, which is represented as a PG pool. So the example that we are seeing here creates a router with a single route, and apart from the route, it registers a state inside of the router. And the state is then automatically passed by Axum into this request handler. You can see that the PG pool itself is wrapped in a state object, but we can easily destructure it, as you have seen before with the query and form and other request extractors as well. So this is a way to get state from service initialization to an actual request handler. The nice thing about state is that if you do use a state request extractor for example, for a PG pool, and you would forget about this with state, the compiler will warn you and it will tell you that this doesn't compile, and it will spit out a long error message about why this function is not a valid handler for your router. There is a way to fix that. There is the macro Axum debug handler, which I think was already mentioned. This is one of the few proc macros in Axum. I honestly couldn't name another from Axum, so maybe there are some, maybe not. But this is a proc macro that is very helpful, especially for beginners. So if you get some unreasonable long error message that you can't deal with, just try adding this on top of your function. Maybe it won't reveal the results right away, but it will certainly nudge you in the right direction, and it will help you figure out what in the world is wrong with my handler. An alternative to using state is called extension. It works in a very similar way. So you register something at the beginning, at the time of initialization of the router, and in here you would use extension instead of the state. The difference between state and extension is that with extension you don't get the fancy compile time checks for your state. So you can choose your path. Do you want the fancy compiler checks with state, or would you prefer to have more freedom with extension? I think both of them have their justified use cases. Maybe there's a third-party crate that you're using for middleware that doesn't really deal with state very well, so it uses an extension. Many times the answer doesn't depend on us. That's what I'm trying to say. So this is what I have about global state. Are there any questions about global state? Or I think that we had a small discussion about that, so I was just wondering if it's clearer now.
Can the global state be mutable?
I believe the global state cannot be mutable. You can use arc mutex to make it mutable if that's needed.
The PG pool variable on the bottom is a reference?
I see your question. So the PG pool here, it is a value, and the way the state works in Axum is that this is required to be clonable.
Okay.
So Axum clones the PG pool into your request handlers on every connection. In case of PG pool, it is probably worth to point out that PG pool internally uses an arc, so it is cheap to clone. Yeah, that was a really excellent question. Thank you.
And I guess it has to be static, right?
Yes, I think it has to be. Because otherwise, the lifetime of PG pool could fall out of sync with the lifetime of the handler. Yeah, we can check the requirements in the documentation, I guess. But yeah, let's save that for after the talk. I still wanted to talk about a couple of things here. One of them is middleware. So let's imagine that we have some reusable piece of functionality that applies to multiple endpoints. So how can we reuse that? In this example, I'm showing a typical example of middleware, which is authentication. I'm using the Axum login crate to add authentication to my user dashboard endpoint, my user dashboard request handler. So the way Axum login works is that we need to add a route layer, which uses login required macro. This is from Axum login, not from Axum itself. So the login required macro, what it does is it looks at all the previous endpoints and essentially protects them with authentication. in practice, that protection basically checks the request headers for some cookies, and if those cookies are set, you're good to go, and if not, you get redirected to this login URL, which is whatever you want to define. Now for the request handler, if you use Axum login, you will get an auth session request extractor, which essentially uses cookies to give you information about the user. I'm not showing the login endpoint here, which is probably the core of login, where you would create the session and put the data into the cookies using Axum login. But if assuming you already have that in place, you could use the auth session request extractor and look at the user that is available in that session. Now there could be a non-user, which I believe is a state where you have seen the browser before, but it's just that the user is logged out or something. But I think you can see that we could easily simplify this match by introducing our own request extractor, like we saw with the user ID. So this is not a big problem for us. There are certainly other types of middleware, but a typical structure is that you register something into a router, and it enables you to use some other request extractor, which also comes with the middleware itself. So this is the main idea here. Any questions about this? No? Okay, let's go on. The next thing I wanted to show you is observability. So when we're running these web services in production, we want to make sure they are properly instrumented and we know what's going on inside of that web service. In Rust, one of the libraries to do that is tracing. Unfortunately, I won't go into details of how to use tracing, but I would like to show you how you can add a middleware which instruments your web server. So let's see, where do we start here? Well, let's start on the bottom. This is easy. We have seen this before, the hello world handler, which just returns hello world. Then before that, we have created a router and registered the route, and we have added a layer. This is another way to add middleware to Axum. Just use the layer function, and the middleware will apply to all the routes that were registered in the router. Now, the creation of the layer, this is actually based on Tower HTTP crate, so we are using Tower Ecosystems tracing middleware, and Tower basically provides this service builder and also this trace layer. So if you wanted to, you can probably see you could chain multiple layers if you'd like. In this case, we just have a single layer, which is a trace layer for HTTP, and this new for HTTP creates some same defaults for you, but if you would like to make changes to that, you can actually specify the function that is called whenever we get a request and we want to create some span. So this function returns a tracing span, which is then used to instrument the request, and this span can then be forwarded to whatever lock consumer you will choose. The tracing subscriber initialization, if I were to describe that really easily, it's just initializing the log collector. It's something that collects the logs and writes them into your terminal, or standard output, standard error output, whatever you choose. So this is how you can create spans whenever you get an HTTP request. You can obviously you have the request available here, so you can obviously take some data from the request and pass that data into the span itself, which I think is very valuable if you'd like to have, for example, the URL that was hit inside of the span, or maybe some significant headers that you're using, like correlation ID or similar. So I think this is very helpful, and it demonstrates the strength of the Tower HTTP ecosystem.
Tomáš, is there a way how to put the entire record into the tracing record?
To put the entire request into the tracing span? So the answer is it depends on how you want to have it in the tracing span. I believe that the tracing library has some implementation details where you can only have 32 fields per span. So if you wanted to include some headers, if you had a request that has too many headers and you wanted to include all of them in the tracing span, they just wouldn't fit. And the other limitation is that the tracing span needs to have all the fields defined up front during the compile time. So you essentially, if the client sends you some header that you're not counting with, it wouldn't be in the tracing span, because there's no way you can name all the headers during compile time. You could technically do something like take the request, serialize it into JSON, and dump it into the span as a JSON string. That is an option. I don't think that's a recommended option. Please check with your observability fellows. So this is how you can solve, how you can partially solve observability with Axum and Tower HTTP. And I think this is this slide is about error handling. So how do we handle errors? What does Axum do if we return a result from our request handler? Basically, in this example, the hello world function is our request handler, and it can return a result. It either returns a static string or it returns some error that I have declared here. The error type is very bare bones. It is not a proper error type, but I wanted to demonstrate that Axum doesn't place any constraints on this other than this implementation of into response. So the error type has to implement into response just to make sure that when the error happens, which is in fact always in this error handler, in this request handler, then the error is convertible to a response. So if this request handler returns my error, then Axum calls this into response implementation on my error. And what this does is that it returns a status code bad request, and it sets the response body to be bad request as well. In this case, the into response function has to return a response always. This doesn't accept anything that can be converted into a response. But if you already have something that can be converted into a response, you might as well just convert it. So I think this is not a big limitation. The one thing that this enables us to do is that we can use our favorite question mark operator inside of the handler, because the handler now returns a result. So there's no need to do matches in handler if something goes wrong. We can just return a result and implement into response on the error type. I think this is very handy. And I think this is the last slide that shows source code. So let's enjoy it. How does Axum help us with testing? So in testing, it is common to have a situation where we want to send a request to the web server without actually binding the web server to some port, because let's imagine we're running like 20 integration tests concurrently. We don't want the integration tests to be taking up the 20 different ports on our machine. And if we want to rerun them in a rapid succession, we would have a problem with freeing up the ports fast enough. So Axum has a solution for that, fortunately. The solution requires that you have some function, you have some way of creating the router in your application. I have shown that like this in my example, that there is some function that creates a router. It essentially creates a router, and it does it somehow, right? So that is a to-do. We will do that later, but we already have tests. So we are doing test-driven development here. We are writing tests first, because that's what we do, right? Okay, so we have a test which is asynchronous, so needs to be annotated with Tokyo test. And inside of tests, we will create a router, and we can use the one-shot function on the router to send a request, which is built like this, to the router. We can then wait for the response, and we can assert on various aspects of the response. So we can, for example, check that the status code that the server has returned here is okay. It's 200. I think this approach to testing is very powerful, and I think the insight that you should take from this is that it is helpful to have a function like this in your application. I believe it will help you not only with testing, but also with some other things. If you were to consider a situation where our application uses a database, we know that the router actually needs to have the database in the global state, right? So that we can use it from the handlers. So the database would then become a parameter to this function so that we can inject the database in both live and testing environments. And then if you want it to be fancy, you could use some abstractions here. So you could have you could ask for an impl trait or a boxdine trait that represents your database essentially. And you could use the same create router function in testing and in live environments, which I think is very desirable. All right. Any more questions about testing? Please don't ask me if I write tests first.
Yeah, now we want to know.
Sometimes. Sometimes I do. Sometimes it's handy to write tests first. But other times you just go and write tests after implementation. It's up to our judgment. Let's just put it that way. And to conclude the presentation, I would like to show you more resources. There is a website called Are We Web Yet? The answer is yes. That's the spoiler. And I added links to Axum documentation, Axum examples, and the Axum login middleware that I was showing before. So yeah, I think this concludes my presentation. That is all I have for you today. And if you guys have any questions, feel free to ask now.
Thank you, Gustav.
Thanks, everybody.